Let's go ahead and look at some problems similar to the ones that are recommended on the final exam study guide. So in chapter 1, I'm just going to do selected problems off the study guide or selected objectives. I thought we'd look at divide complex numbers and write in standard form. So complex numbers are things like 2 minus 4i, that type of thing. So this objective said divide complex numbers. So if you had something like 4 divided by 3 minus 2i, the issue is remember that I is really equal to the square root of -1. So it's a radical. So you have a radical in the denominator. So what we're going to do is we're going to work on rewriting this and putting it in complex number form. So it'll look like that right there. Okay. So it's sort of like rationalizing the denominator that you did in Math 100 when you had radicals. So remember that if I equals the square root of -1, we know that I squared itself is equal to -1. So we're going to be using that fact in a moment. So on this particular problem, what you would do is look at your denominator and you would multiply by the conjugate of that denominator. So you'd multiply by 3 plus 2i. So whatever you put in the first and the second slot would be the same, but if it was a minus to start with, you would need a plus there. And then whatever you do to the bottom of the fraction, you also have to do to the numerator in order to not have changed the problem. Now, the reason we do this is once we multiply that denominator out, we're going to wind up having all the i's disappear. So we're utilizing that fact that when you multiply two binomials that look like this, you wind up having just two terms. The middle term cancels out. So let's go ahead and do some distributing and some multiplying out and see what happens. So when we distribute the 4 on top, we'll have 12 plus 8i on top. In the denominator, we have two binomials, so we're going to FOIL that out. We're going to get 9 plus 6i. So we'll have 9 plus 6i, and then we have to distribute the -2i to both. So we'll have a -6i, because a negative times a positive would be negative, and then a -2i and a +2i would be negative. 2 times 2 is 4, and I times I would be I squared. All right, so now at this point, notice that the 6i and the -6i would add up to be 0, so they cancel out. And the I squared that we have right here, we can replace with a -1. So we really have 12 plus 8i, and this right here, we're going to replace with a -1. So we really have 12 plus 8i on top, and we have 9, and then minus 4 times a -1. See, that I squared is really a -1. So -4 times a -1 turns out to be plus 4. And so here we've pretty much got it. We just need to go ahead and combine the 9 and the 4. And then on these problems, if they say write it in complex number form, then they're expecting you to separate it into a plus bi. So you would do that, and you might even see it written where the I is off to the right of that 8/13. Okay, but that's one of the good things about the multiple choice test. They won't have this as an answer and that as an answer, right? They're not going to be checking whether you have it in the correct form. You can just look at the answer choices, and you need to be able to recognize which of the answer choices is equivalent to what you got. So you might have thought this was it, but then you need to recognize that 12 over 13 plus 8 over 13i is equivalent to it. Okay? All right, you'd also have to fully simplify, and sometimes we mess that up. So let me ask you this. If this had been, say it had been 12 plus 8i, and it was over 6. Okay. For this problem, you would separate it into 12 over 6 plus 8i over 6, and then simplify each fraction. So that would be 2 plus, and then 2 would go into both 8 and 6 and give you 4/3 I, and that would be your final answer. So you do need to be sure you fully simplify and that you simplify correctly. Like over here, it's not okay just to say 6 goes into 12 twice and think that your answer is going to be 2 plus 8i. See how that would not be correct. So I just wanted to show you that. So to be careful on your simplifying, okay? Okay, so let me get it back to what it was. All right. All right, now another one from chapter 1 says to solve by the square root method. So this was dividing complex numbers. And it's just like rationalizing radicals. Okay. All right, and then the second one they had is the square root method. The second one I want to do is the square root method. Get some paper here. All right, so if you had a problem like this. So if it said solve using square root method, then it's going to be a problem that would be probably best done using that method. So something like this, if you had x minus 4 in parentheses squared, minus 2 equals 46, something like that. Something where it would be possible to try to isolate the thing getting squared. That's when the square root method works well. So what you would do on this one is you would add 2 first, and you would do that to get rid of the minus 2 to try to get whatever's being squared needs to be on a side by itself. All right, now once you make that happen, then you're ready to undo the squaring. So the next step would be to come in and take the square root of both sides. All right, and when you do that, don't forget that there's going to be a plus or minus because you got 2 square roots of any number. And the symbol, when we write this symbol, it's just the positive square root. So we need both of them. So by doing the square root, we've undone the squaring here. So we're just going to have x minus 4. And then over here, we need to take the 48 and we need to break it down. All right, there's several ways to do it. One way to do it is to think about your perfect squares. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, and so on. And then you start at those larger numbers and you say, well, 25 doesn't go into 48, but 16 does, and you split 48 into 16 times 3. So the square root of 48 would be equal to the square root of 16 times the square root of 3, and then you can simplify the square root of 16 to get 4 square root of 3. So that's a good way to do it, especially when the numbers are kind of small, okay? And then the other way to do it, let me just make this a little shorter here. The other way to do it is to take the 48 and just get it broken down into its prime factors. So you might have thought 6 and 8, 2 and 3, 2 and 4, and then 4 is 2 and 2. And so you had 1, 2, 3, 4 2s and a 3. And you're trying to do the square root of this. So you need a pair of factors to have a perfect square. 2 times 2 is 4. So you can do the square root of that, okay? The square root of the other 2 times 2, and then there's 1 left over. So normally what you do is you just go from here to here. You say, okay, so there's a pair. So when I do the square root of 4, I'll get 2. Okay. Here's another pair. When I do the square root of 4, I'll get 2. And then I have a 3 that's still trapped underneath the radical. So all of that was to get square root of 48 into simplest radical form, which is 4 square root of 3. And there's a plus or minus, don't forget, still out in front. Now we needed x. Okay, we have the 4 there that we need to get rid of at this point, so we're going to add 4. All right, and so we wind up with x equaling positive 4 plus or minus 4 square root of 3. And then that would be your answer. And it would probably be written that way, but it means the same as that. Okay, that you have those 2 answers. Okay, all right, so solving using the square root method. All right, so that's all I wanted to show from chapter 2.